Well, what do we have here today, huh? This is a Hewlett-Packard 400E AC voltmeter. Now, that in itself doesn't really say a whole lot. Um, an analog AC voltmeter may not seem like much to a lot of you folks today. But this is not just an analog AC. This is a high-frequency AC voltmeter. This voltmeter was top of the line for a while at Hewlett-Packard. It will read accurately up to about 10 megahertz, and it's usable up to 30 megahertz. It has inputs that are capable of reading 300 volts down to a millivolt, full scale, at 10 megahertz plus. So this is not just an AC voltmeter. The unit's in nice shape, unbelievable shape for its age. A little bit of a sticker residue here that won't rub out. I tried. That's about the worst spot on the whole unit. The case is remarkable on this particular model. Inside it's a cast metal frame. It's got a lot of heavy-duty shielding in there, and you've got shielded panels that are held on by screws. Got a nice wire stand that folds out. We have battery capability. You can run it off of 35 volts DC on the back here. You have analog output. Runs off of 110. And as you can see, she's a beauty. We're going to take it through its paces, and I'm going to show you what I mean about its frequency response and why it deserves consideration for your bench, especially if you work on, let's say shortwave, ham radio, that kind of thing. The frequencies would put you right up in that realm, and this would give you capability to do some readings right on it. About the only thing that I know that that's capable of doing that otherwise would be, something along the line of a Boonton RF meter, Motorola, which is a Boonton knockoff, so on. Those are quite expensive. They take special probes. This one is a direct reading. It just you can feed it right on off of a BNC connector, and you're off and running. So let's give it a go. Hang on with me. I'm going to hook this thing up and we'll take you through it. Alright, I've hooked the Hewlett-Packard 400E up to this Gersh ratio transformer. The ratio transformer is going to give me just easy access to dial in the voltages that I want to measure with. And I'm feeding in my calibrating voltage from this Hewlett-Packard 5200A calibration unit back here. We're feeding 10 volts AC at 400 hertz right now. And it's 10.00000 volts. So with that voltage coming in, then I can use the ratio dials on the Gersh to dial in whatever voltage I want to read on the meter. Right now, I am reading on the 10 volt scale. I am reading a full scale reading of 1, so that'd be 10 volts. And do my best so you try and let you see what's going on here. Now let's go ahead and dial in 9, 8, there's 0.8, 7, 6, 5, 4. arm is in the way of the light, I'm sorry. 3, 2, well, let's leave it at 3. Okay. Yeah, we'll take it down one. There's 1. That's 2, and here's 1. Alright, so we've traversed the whole scale, and all the steps were perfect. Let's go back up to 3. That should be 3 right there. And it is. Alright, so let's change our range to the 3 volt. And we see ourselves raise up to the 3 volt maximum on the range. That's good. Okay. This would be 2 volts. This would be 1. Good. Now we go to the 1 volt range. We see ourselves go up full scale. That's good. We're at 1. Alright, so here's 0.9, 0.8, 0.7, 6, 5, 4, 3, 2, 1. Okay, so let's our next step would be 0.3 maximum, so let's get back up to 3. Alright. Go ahead and take ourselves to 0.3. And yes, we hit the 3 mark. Okay. Here would be 2, 1. That would be that's 0.1 volts. I go to the 0.1 volt scale. We should go up to full scale. We did. And let us go to 0.9, 8, 7. This is 0.07, 0.06, 0.05, 0.04, 0.03, 0.02. That would be 0.01. And I'm going to take us back up to 3 again. Alright, there's 0.03. So we go down to the next scale. And yes, we go back up to the 3 reading. And here would be 2, 1. Alright. And we go down to the 0.01 full scale range. And there we are at 100th of a volt full scale. Would be 0.009, 0.008, 0.007, 6, 5, 4, 3, 2, 1. Let's get this. Okay. Everything reacted well. Let's get back to 0.003. That would put us at the 3 millivolt full scale range. There we are. Full scale, 3 millivolts. This would be 2 millivolts, 1 millivolt. Right, just a hair high on 1. Getting maybe a little noise. Okay, in order to eliminate some of the noise from that I was picking up from the Gersh and the surrounding electric wires at the smallest setting of 1 millivolt full scale, I've now connected with a coaxial cable directly to my flute calibration standard, and that seems to have quieted everything down considerably. Right now I am feeding in a millivolt full scale at 400 Hertz, and we are at full scale. And then we're going to go and step it down. This would be 9/10, 8/10, 7/10, 6, 5, 4, 3, 2, and 1. 1/10 of a millivolt, 400 hertz. Okay. Let's take ourselves up in frequency, and we're going to go, this is at 10 kilohertz right now. Alright, so we've gone up in frequency on the fluke. We're at, I don't know if you can see this scale right now, but we are at 10 kilohertz on the fluke. We're feeding in, well, at the moment, 1/10 of a millivolt, but we're going to go stepping it up. Applying power. There's our 10th. 2/10, 3/10, 4/10, 5, 6, 7, 8, 9, full scale at a millivolt. Okay. And let's go ahead and take ourselves up to 100,000 hertz, and we'll step her back down. Okay. All right, right now we are feeding in 100,000 hertz off of the fluke. Again, I hope you can see that. We are full scale at a millivolt, and we're going to step down. 9/10, 8, 7/10, 6/10, 5/10, 4/10, 3/10, 2/10, 1/10. Okay. Oops. 1/10. Okay. Well, the problem that I have to face in the high frequency end of things here is that I just don't have any equipment that will provide the variation in frequency without sacrificing somewhere in the level. And I really need to maintain the level accurately in order to be able to reflect the frequency response on this meter. So the way we're going to go around solving this little problem is we're going to utilize this 100 megahertz scope. This scope has 10 times the bandwidth of 10 megahertz, so we're going to believe that the scope can produce the accuracy we want at 10 meg, and we're going to adjust our meter at, say, 100 kilohertz. We'll adjust for 1 volt full scale. We're going to take a look at our oscilloscope, and we're going to see what that represents on the scope. Right, we're just going to look for relative peak. So we're going to know that whatever we achieve on the scope when the meter is showing full scale is what we want to show on the scope when we switch our frequency higher. We'll adjust again to get the same value on the scope, and then we'll take a look at the meter and see what we hit. So let's give it a try. Right now we're a little less than full scale, so we're going to raise ourselves up. That looks to be dead on. Alright. So this is at 100 kilohertz. We are getting 1 volt input right now out of our generator. So let's take a look at our scope, and let's see what 1 volt going into our meter looks like on the scope. Okay. And essentially We're getting a reading here of going up 2.7 divisions. The thing is, we want to make sure that when we step up our frequency, that we maintain 2.7 divisions on our output. So let's go ahead and raise the frequency up. Here would be megahertz. Little jump, but it's pretty much right there. Let's go to 10 megahertz. Alright, looks like we rose slightly. And the way it looks to me, we're going to need to bring it down. Let's try it here. That looks to be about it right there. So let's see what that looks like on the meter. We're at 10 megahertz now. And what we're hoping is that we're going to see a 1. By golly, there she is. Just a thread over 1. But we're at 1. And that's at 10 megahertz. Now we could do the same thing. In fact, I think we will. Let's do the same thing and we'll go up even higher in scale and see just what she does. Okay, so what I've got right now, I've got my RF generator feeding in approximately 4 megahertz, and we are reading, I set myself up so that we are reading right on the plus 2 dB scale. This will be the lower scale, it's written in dB. And what I'm going to do is I'm going to raise my frequency. I'm going to verify that my amplitude is the same at the higher frequency. And I will adjust it to make sure that it's the same, and I'll use my oscilloscope as the control device for the amplitude. And we're going to try and find the 3 dB drop-off point. I've already done this, so I happen to know it's 24 megahertz, but we're going to show you that. So right now we are plus 2 dB on the scale, and we're dead on. 4 megahertz input. We're going to take the connector off. We're going to go on our scope up here. We're taking a look at the relative amplitude, and what I'm seeing is 2.7 divisions up. Okay, so then we're going to raise ourselves up 10, 20. I've got 24 megahertz coming in here now. There's a 2 and a 4 on those dials. The rest of them are 0. 24 megahertz. And I'm going to make sure that I have myself adjusted for exactly 2.7. And that looks to be it right there. 2.7 again. I don't know if you can see that, but that's what it is. So now we're going to take the connector off, going back to the meter, and what we see is that we've gone from the plus 2 past the 0, so we lost 2 dB right there, and we're just about a dB down further. So we're 3 dB down roughly at 24 megahertz. Actually, there's just a slight bit more left to go before we'd hit the 3 dB, so maybe 24 and a half, something like that. But let's go ahead and we're going to go reverse the process. Just make sure that we come back where we should. Alright, let's go 10, 0. Now we're at 4 megahertz coming in. And we adjust our amplitude for exactly 2.7 divisions. There we go. And if I take the test connection and I connect myself back up to the meter, I should be back up on a plus 2 mark if everything went right. There we are, plus 2. So we're on the 1 volt full scale range, and we are showing that we have a 3 dB point at 24 megahertz. So there we go. Okay, so it's a beautiful meter. Extended frequency range, there's little like it out there, frankly, unless you get an RF meter. And it's accurate. We've checked all of the ranges. We're getting accuracy on it. And it's going to come with this Hewlett-Packard operating and service manual, which goes into the specifications, theory of operation and theory, and goes through the calibration procedures, accuracy checks, and then finally parts and schematics. And I've taken some time and provided these on fold-out pages. So as you can see, I've taken some time and I've given you a fold-out here, just like in the original manual. Took a little bit of work to get all the pages together, but there we are. So we have the schematic diagrams, the parts list, the part locations, everything we need to check out the unit, addendums and so on. So that'll come with it. You'll be in good shape. Thank you for listening. Happy bidding.